Now, in the second session, we must know how to write program and the format by which we must write the program. So here are certain tricks that we have to follow while writing the program. Okay, and there are so many formats previously available, like tab sequential format available, fixed format was available, but those formats were 20 old, and the word address format replaced them all because of its wide adaptability, and reading of the part program and preparation of part program would be easier. So what in word address format, how do we program is like every numbers, if you see 20, 0, 1, 1.2, 0.1, every number is being preceded by some alphabets. Every number is preceded by alphabet. It means that हर एक numbers के आगे एक alphabet रहेगा. अभी 20 के आगे n का लिखा है, तो what n stands for? n stands for sequence number. जैसे कि प्रोग्राम में लिख रहा हूं तो 60-70 लाइंस का प्रोग्राम है, तो मैं किस तरह नंबर्स लिखूंगा? and 20 and 10, 20 and 30 and 40. Likewise, I will be writing the program in this manner. Okay, and you must be having the question like why we are keeping space of 10 in between the two subsequent lines. It is because suppose that I wanted to modify and add one more line in between these two lines, so I could be write an 11 and 12 or and so on, depends on the number of line I would be able to add. So it is advisable to keep a space of 10, 20, 30 in between this. So if the number is preceded by n numbers, it means that it is being interpreted by the machine as of sequence number. It is the sequence by which the machine will read and machine will operate the sequence of the program. Okay, now the second part is preparatory function. So if the number is preceded by G code, if the number is preceded by G is a preparatory function. G is a preparatory function. If the number is preceded by G, then it will operate the machine at that. Suppose that let me explain the meaning of G01. G01 stands for linear interpolation. G01 stands for linear interpolation. Linear interpolation, it means that I will be defining the feed. So here you can refer this 325 is being preceded by F. So that is a feed function. So this machine will be operated at a feed rate of 325 mm per minute. The machine will be operated by 325 mm per minute. Okay, so that is why if it is like G0, suppose that I have written instead of G01, if I write G00, then the machine will operate at a speed of maximum, which is 24,000 rapid interpolation speed, which is being defined while purchasing the machine. It is a machine specification category. So for turning center DX150, that range is 24,000 mm per minute. So if I write G00, then the coordinate will be reached to a particular location with a speed of 24,000 mm per minute. And if I have written G01, then it will reach to the machine at a speed rate of 325 mm per minute. Now the second, so the sequence number and the preparatory function are clear. Then we will be having coordinates x, y, and z. Our turning center is having only x and z. It does not include y. So we should be writing x, which is preceded by a certain coordinates, y or z, which is also preceded by some coordinates. Then if the function or numbers is preceded by f stands for feed rate. Feed rate can be in two sense. Okay, feed rate can be there in two sense. One is mm per minute and mm per revolution. Let us say feed rate, if I write 0.15 to 0.4 mm per revolution, and I could be writing 200 to 400 mm per minute. Okay, I can give feed rate in two sense. One is if it is a turning center or CNC lathe, I should be writing feed rate in mm per revolution. And if it is vertical machining center, that is milling center, then I should be giving the feed rate in millimeter per minute. It is a linear feed and it is a rotary feed. Okay, so in order to actuate this, we will be using certain specific G function that we will be seeing. Okay, so feed rate can be in two sense. Here, if it is 325, obviously it must be in mm per minute. Now the 1000 is preceded by what? S. S stands for spindle RPM. F stands for spindle RPM. So the chuck will rotate it, or workpiece will be rotated by 1000 revolutions per minute. Now the next is T03. T03 does 03 stand number. If the 03 is preceded by T, if the it is preceded by 3. Okay, M09 stands for coolant on. M0 is a miscellaneous code. Here you can see. Okay, M09, sorry, just a moment. M09 stands for, M stands for miscellaneous code, and 09 along with M stands for coolant off. M0 and M08 stands for coolant on, M09 stands for coolant on. So that is nothing but a miscellaneous code. And EOB stands for end of block. See, if we write program on line 1 and we wanted to jump to the line 2, we will press input button in the machine controller that I have stated. It is a yellow color button. It is the only yellow color button. Previously, how we were doing, we will be writing this symbol. We were writing this symbol so that we can enter to the new line, so that the machine will, once this symbol is read by the machine, it will interpret that this block is over. Entire this line is being said as a single block. Okay, so this entire line and 20 up to this, it is being interpreted by one block. Okay, suppose that if I am writing the program like G0 X42 Z2, then I new line, if I will be writing X38, then I will be writing G0 G01 G0 X40 Z2. So it has three blocks: block number 1, block number 2, and block number 3. Okay, and previously we have to show this symbol while writing the program, but nowadays we are having input button in the computer itself, so no need to write that. We just press the input yellow color button onto the screen. Okay, any doubt within this? The difference between speed and feed. Okay, Muhammad. Yes, Mohammed. The difference between speed and feed is the speed here, the speed in terms of RPM, and feed in terms of linear movement of the tool or a workpiece. Okay. Any other question? Did you get, Mohammed? Okay. Anything so far within this? So you must write the program in this manner. It should not be written like that. We starting with G01X and so, and we will be writing N20 at the end. It must be written in the particular sequence. Yes, Jay, there are so many cycles, but that is our the third day session. I will be explaining how do you cycle. Nowadays, end of block should not be written on the computer, nor the symbol of colon should be there on the machine. Okay, nowadays we just need to input, we just need to press input button to enter to the new line. But if we are writing the program on a piece of a page, then it is better to then it is advisable to write either end of block as of word, or the or represent the symbol so that the others can understand. Okay, if only you could say about T03. I mean, does it stand? T03 stands for tool number 3. If I will write M06T2, if I will write simple, not entire line, but I will just write M06T2, the machine will change from the current tool to the tool number 2. That is the meaning of T03 or T02 meaning. And there should not be space between that. It should be continue. Okay. T03 stands for tool change. Okay, Param? Okay. Now, let us see the next. Yes, sir, where to assign this tool meant for this specific? See, this is just a generalized block. Once we start programming, I will be sharing the details regarding where to write what. Okay, so don't worry for now. Don't worry for it. We will be explaining once we start the program, but this is just the format so that you will be understood that how you will be starting writing the program. Okay, that is just a generalized block. We will write in a specific manner when we start the programming of a particular component. Would that be okay, Mela? Okay, okay. Now let us jump to the next slide. Now before starting, suppose I have to change tool. So every time offset measurement. No, before starting manufacturing, you must select the tool that you will be using throughout the program, and you have to take work offset for each and every tools. Okay, Kaushik? For that, if you are using 3 tools in a particular program, then you have to take all the offset of each and every tool, which means that you have to take offset 3 times in the beginning of the programming. Okay, is that clear, Kaushik? See, now absolute dimensioning. Suppose that we are having a job and we have, see, there are 2 types of way. There are 2 ways by which we can do programming. One is absolute and one is incremental. So we must know the dimensioning pattern of the absolute and incremental. And in absolute way, the dimension is being measured with respect to single 0 0 point. So here you can see we are having this coordinate 0 0, and this is the point where we will do work offset. I will explain the work offset later on when we start the program, but you can assume this point as x as a 0 coordinate and z as a 0 coordinate. This one is x coordinate and this one is your z coordinate. So the every dimension, suppose that uh, if we are having step shaft, let us take this as a dia 40, diameter 20. I just have represented the only half part, and the depth between this two, uh, let us say it is 15 mm depth. Okay, So suppose that if I wanted to indicate this point, suppose that if I wanted to indicate this point, then how do I indicate this point with respect to this point? This point for me, it is 0, 0. In this direction, as I said, lengthwise it is z, and the diameter wise this would be x plus, and on this side it is z plus. So from this point to this point, see, we must ensure that we will be writing uh, x coordinate in diameter. We will be writing x coordinate in diameter and z in length. Okay, so this point, at this point, the diameter of the raw material would be 20 and the z would be 0. So coordinate for this point would be 20, 0. The coordinate for this point would be 20, 0. Coordinate of this point, at this location, my x would be 20 and my z would be what? Z, and here it is 0. So this coordinate would be minus 15. So it is z minus 15. Got it? So this is nothing but absolute dimensioning. If you are having any doubt within this absolute dimensioning, you must ask us right now, as it is very important just before starting of the program. Let us take one more example. Okay. Here diameter 20, here diameter 20, and here is diameter 30, and all are the steps of 10 and 10. And let me give the number 1, 2, 3, 4, and 5. Can anybody give me the coordinate of point number 1? Just put that on chat box. Anybody can give me the coordinate of point number 1. Make sure that you write x as in diameter and z as of single. So x will be double. Okay, and for all of us, at this point is 0, 0. This is your z plus axis, and this is your x plus. Yes, Jaipal. Yes, it would be. This would be tan 0. Now, what about point number 2? Point number 2. Nice. Arav, Jaipal, Kaushik, Virendra. Good work. What about point number 2? Yes, point number 2 would be same, because x would be 10 throughout this line. So it is 10, and in z we will be moving minus 10. So it is minus 10. What about point number 3? What about point number 3? Yes, exactly. Point number 3 would be 20 and minus 30. Good work. And what about point number 5? Let us skip point number 5. Just give me the point number 5. Point number 5. The diameter at point number 5 would be what? It would be 30 in diameter. Nice work, guys. And 10 plus 10. It would be 20 in depth. So it is 30 minus 20. Do you get the dimensioning pattern using absolute? We are considering dimension of point number 5 with respect to this origin point. Point number 4, 3, 2, and 1. All the points we are measuring with respect to the 0, 0 point. So that is what, nothing but absolute dimensioning. And here you, if you read, all positions measured from single 0. That is what the process in here. Okay, so it is basic and simple, I think. Okay, now let us talk about the other dimensioning method, that is incremental dimensioning. That is incremental. Incremental is also being represented as a relative dimensioning. In this case, what is the difference? That we will be having first point as a 0, 0. First point we will be having a 0 0, but in the next point what will be this point? The next point would be measured with respect to previous point. Now again the third point would be measured with respect to its previous point, which is point number 2. Let me give it a number 1 2 3 4 and 5. Now the location of point number 4 will be measured with respect to point number 3, and similarly this point will be measured with respect to 5. Now let us assume that all this gap are of 10 mm. It simply means that all the points are passed at a distance of 10 mm. Now suppose that point number 2 point number 3 should be measured from point number 2. So point number 3, for point number 3, this point is a reference point. This point should be the previous point, should be the reference point. So this distance is 10. So considering this as a 0 0, so this point would be minus 10 and 0. Similarly, point number 4, this gap is 10. For this point should be 0 0. So it should be what? It should be again minus 10 0. And for this also this should be minus 10 and 0. Okay, any doubt within this? Okay, let us clear this topic with some more examples. Okay. Okay, now suppose that if we have the again step shaft, we have the diameter 10, here diameter 20, and this gap is of 15 mm. For you this point is offset point and it is 0 0. This direction is z and this direction is x. Okay, now can anybody tell me the coordinate of point number 1, point number 2 and point number 3? I just need the coordinates of point number 1 now. Tell me the coordinates of point number 1. For point number 1, x 10 and z 0. Okay, yes, exactly. For point number 1, x should be 10 and z should be 0. What about point number 2? Point number 2. Point number 2. Just think and answer. No need to worry and answer. For point number 2, the 1 should be 0 0. While getting this point number 2, the point number 1 should be 0 0. No. All the answers were wrong. Considering, see, if you wanted to get this, consider this as a 0 0 and identify coordinate for point number 2. Exactly, Eric. Nice one, Eric. It should be 0 and minus 15. Because we are just moving in z direction by 15 mm. We are just moving in z direction by how much? From this point to this point, the distance is only 15 mm. So x should not be changed. Okay, so x would be 0 and z would be minus 15. Okay, nice work. Okay, now can anybody tell me what about point number 3? Point number 3, point number 2 must be 0. Point number 3 would be the same, 10 0. Nice work. Okay, see, while giving this, do not hurry in answering, but make sure that your answer is correct and you learn the topic thoroughly, because this entire program is related to only coordinates. If the coordinates are wrong, then there will be wrong coordination of tool workpiece, and if that happens, so you will be seeing the either tool is being broken or the workpiece is being broken, and we need to call for calibration and maintenance guide, which may cost 10-20,000 rupees for the silly mistake. So since it is a costly machines, we should be operating wisely. Okay. Any doubt within this absolute and incremental? Let me repeat it simply one more time, that in absolute there will be only 1 0, but in case of incremental, the previous point would be considered as a reference point or a 0 point. That is the difference between absolute dimensioning and relative dimensioning. Okay. Now we should know the little bit about uh, G codes and M codes. We should be knowing a little bit about G codes and M codes. And before doing it, let me prepare you one simple code for all of you guys so that you will be able to understand how the code is being built. Suppose that I wanted to make this simple job. Here, the diameter is 20, and in here, the diameter is 40. And we will be taking most of the time same example, and this gap is 15 mm. Okay. So the raw material would be like this. We have to remove this part. We have to remove this rectangle. Okay. And for this, let us take CNMG. CNMG means it must have angle 80 degree, and it is of rhombus shape. If we see it totally, it would be of this shape, the two. Okay. Now let us assume that the tool now at current time the tool is at this location. Just assume that the tool is at this location. Tool has to reach from that location to this nearest location. Initially, the tool is at point number 1 and it has to reach to point number 2. Okay. So I should be writing just basic program, not the entire. I will just write 4 to 5 lines program so that you will be able to understand the codes which we will be learning just after this. Okay. So if I will be writing G0 X 45 and Z2. What does it means? That tool currently tool is at any position which can be 1, but I need the tool to be at X40. So from this point, this distance would be 45 in diameter. So half of the above and half should be below. So it should be 45 by 2, but we will be writing X coordinate in diameter. Okay, so it will be X45. And for the safety distance, we will be keeping it 2 mm away so that the tool does not directly collide with workpiece. Otherwise, its front tip will be chopped off. Okay, अगर उससे क्या होता है कि उसके फ्रंट की जो टिप रहती है ना वो एक झटके से निकल जाती है और वो निकल गई, it means that the tool is being broken. So yes, now what does this mean? G0 mean? G0 means rapid interpolation. G0 means rapid interpolation. For DX150, the rapid interpolation should be, the rapid interpolation is 24,000 mm per minute. So the stool will start running rapidly. The stool will start running rapidly as it has read the G0 code. And it has to reach to which coordinate? The destination coordinate is X45 and Z2. So the tool will reach to this location with this fit rate. That is what the meaning of rapid interpolation. If it goes very slowly from this point number 1 to point number 2, very slow, it is just the wastage of time. And to this movement from point number 1 to point number 2, since there is no machining is being happening, we can call it non-cutting movement. We can call this as a non-cutting movements. This must be non-cutting movements. Okay. So Do you got the meaning of the first line? It is G0, X45, Z2. Now what we have to do then after? We have to lower down the tool. We just have to lower down the tool. We just have to lower down the tool to which coordinate? To the coordinate of, see, this is 40 mm, so we must remove 2 mm in diameter, which means that 1 mm in depth of cut. So this coordinate in X would be 38. So I will be lowering down the tool X 38. I am just lowering down from this point number 2 to the next position, which is 3 number. So it is point number 2 to point number 3. Just shifting the tool from this location to this location. Okay. So that is X38. Since I am writing only X38, Z will be remain same. So Z will be 2. If I will write Z2, it's fine. If I will not write Z2, then also it is the same, because I'm just moving in X direction only. Okay. Shit. Okay. Just a moment. There is some technical issue. I just need to redraw it one more time for you. So this will be the workpiece. I'm just repeating it one more time because that screen went off. Okay, this will be my 0, 0. This will be my Z plus axis. The above will be my X plus. Okay. The diameter at this location is dia 20. At this location, my diameter is 40. And let us say my current position of tool, which is CNMG, is at somewhere around this location, and that location I'm giving it a 1 number. Now let me represent some of the portion of the raw material which we have to remove it. Okay, so we have to bring down tool from that far more location to the nearest location, and I'm just drawing the tool. Okay, and let me give that point number 2. So what we have to write in order to move from one number to point number 2, that is G0, which is linear interpolation, G0, X 45 and Z2. Like I have explained just now that if we write X40 and Z0, the tool will directly colloid to the workpiece, which should not be done. Tool should be somewhere nearer to the workpiece. I will address the question later on, so just be patient. Your question will be answered. Now we have to move from, since we start to cut, we have to move from point number 2 to point number 3. We have to move from point number 2 to point number 3, and for that we have to write X38. So up till now it is X40, and then after we will be lowering down to 2 mm. So it is 40 minus 2, that is 38. Now we have to write what? G01. See, since we are start cutting, we have to move the tool from that location to the 4th point. Okay, and this depth is 15 mm. This depth is 15 mm. So what we should write? G01. See, once we start cutting, when we start cutting, we should reduce the speed, because at 24,000 mm per minute we should not cut the tool. So we will be lowering down the feed rates, and since it is rough cut, I will be putting this little bit higher amount of feed rate. So G01. Now, what would be the coordinate of point number 4? Can I say that point would be only in the Z, which is Z minus 15. From here to here, this is at here Z02. At this location, Z is 0. And at this location, Z is minus 15. But in previous line, what we have wrote? We have wrote X38. So X38 will remain as it is, only it will change to the direction of Z. Okay, that is minus 15. And since it is G01, we have to define the feed. And I'm defining the feed rate as 0.5. I can write 0.4 also. Here the unit of the feed rate is mm per revolution. So every revolution the tool will move inside by 0.5. Since it is a rough cut, I would be opting that. If it is a final or finished cut, I should be opting 0.1, 0.15 or 0.2 feed rate. Okay. So I just wrote 3 lines and 4. Now we have to get back to point number 2. Now we have to reach from this point number 4 to point number 2. Since we have removed the material, we should not go back to the point number 2 with a lower feed rate. We can write again rapid command. It is G0, X45 and Z2. Okay, so this is nothing but the lines. See, this is G0x45. At here you will reach point number 2. At here you will reach point number 3. At here you will reach point number 4. And here again you will reach back to point number 2. Okay. So this is what the program. Now let me see your question. At meet. Sir, I want to know how you calculate the value D20. There is no D20 here. I don't know the question at meet. Amit Lainka, what is Z2? Z2 is a safety distance. We can call it a retract distance. Since the tool which is from here, it should not touch to the surface rapidly. So what we are doing, we are moving from here to nearest position rapidly. Then we are just engaging it lowerly, and then we are start engaging slowly, so that the tool directly does not chopped off its nose radius or front face. Okay. Is it clear, Amit? Param? No, it should not be Z minus 17. What I said, point number 3, at point number 3, Z is 2. Okay. The front face somewhere around here. See, at this location. Again, the screen went off, so I won't be able to see. But let me clearly for you. See, this is point number 2, this is point number 3, and this is point number 4. Okay, so at here Z is 2, at here Z is 0, and at here Z is minus 15. So Z is a coordinate, not the distance travel. So Z should not be minus 7, it must be Z minus 15. And yes, it is important to type feed in every G01. Now every time we should